We're going to go ahead and finish up chapter 43, animal behavior today. Some pretty cool topics. I am still a little under the weather, so I apologize in advance for the sniffling, kind of gross voice that I'm going to have today. So we left off last time talking about mating territories and the example of having a lek as an example of choosing a mating partner or perhaps many partners. Here you have several examples of how some organisms are trying to impress a choosy female, because we said females were often the limiting factor in mating. So here you have a hanging fly. That's this guy here. And he has caught and killed a moth. And he is presenting that moth to his potential mate to show her what a great hunter he is, I guess. And here you have fiddler crabs. They have one claw that's much bigger than the others. And they will kind of wave that one big claw to attract the female fiddler crabs, who have two very small claws. And then here you have male sage grouse on a lek, which is really just a flat piece of prairie with lots of visibility. And they dance, puff out their neck, and make these weird booming calls. But of course, like we mentioned before, that communication is also dangerous, because while the female grouse can hear those booming calls, so can owls, and so can coyotes, and so can foxes. So there's risk involved there, but he must think it's worth it because he's out there displaying. So in about 90% of mammals, females are going to raise the young. Both sexes are going to participate in the remaining 10%. But female mammals have a lot greater investment because they sustain the developing young in their bodies. Female mammals also, of course, nurse their young. And there are some exceptions, really only two that we know of. And there's two fruit bat species in which both the males and the females are able to lactate and nurse the young. So you see a little more male involvement in raising the young in those situations. With fishes, a lot of them don't provide any parental care. They'll just lay the eggs, and if they make it, they make it. If they don't, it's no big deal. In the few fish species that we see that do actually take care of their kids, it's normally the guy who takes care of the kids, and we don't really know why this is. It might be fish fertility. Females' fertility increases with age, and a male does not. So the first batch or two of kids that male fish has is probably about the best batch he's gonna have, and so he's gonna want to take care of those a little bit better, as opposed to the female, who will literally just get better with age, so she can kind of scrub those first two batches and give them to the male and pay more attention to the later batches of eggs. In birds, most of the time we're going to see two-parent care because baby chicks just eat a lot. The young tend to hatch in a relatively helpless state. There are two types of birds. There's precocial and altricial, and then there's super precocial, true. But precocial chicks are like pheasants. They're born feathers, ready to run, and they just take off. Altricial chicks are born blind, featherless, and helpless. And so it takes a lot of parent care to get them to adulthood, or to at least fledging. And so the two parents are going to do better because they're going to be able to find a lot more food. There are some species in which the female alone provides the care, and in that case it's normally precocial chicks like pheasants, and when they hatch they're not all blind and naked. They have feathers and they're ready to go, and mom pretty much just leads them to food, and those chicks start doing their thing. And then there's something called super precocial, where mom incubates her eggs in a huge pile of decaying leaves, and she's not even around when they're born. They just take off on their own. So here you have some examples of parenting. There's a female grizzly caring for her cubs for up to 2 years. It's a difficult job because a male bear will oftentimes kill and eat the young bear, because once the mother is no longer taking care of them, they'll go into ovulation quicker and he'll have a better chance of breeding with them. So kind of a dark thing, but that's the way it goes. So female bears put a ton of time and energy into raising the kids. Here you have the Finding Nemo example of a male clownfish, and there's the tiny Nemo and his, hundreds of brothers and sisters that he's guarding the eggs until they hatch. And then here we have a tern, which is basically like a seagull, and they're both working together to care for the chick because it's going to need to eat pretty constantly. So with a lot of animals, we see them living together as a group. Pardon me. Ugh, excuse me. with a lot of animals, we see them living together in a group. There are benefits and costs to this. One example of group living where it's generally beneficial is what's called a selfish herd. And a selfish herd is kind of like fish schooling together. There's temporary aggression when the individual mammals move near others to minimize their own risk of predation. So it's basically like we don't want to be around each other, but if we're all herded up, it's less likely that any one of us is going to be eaten by a predator. So that's a selfish herd. Benefits of grouping, you have lots of eyes. There's multiple individuals to be on the alert for predators. And when you all start to run away at the same time, it can be very, very confusing for the predator to just pick one fish or just pick one duck when there's thousands of fish or thousands of ducks and they're all flying in a different direction. It's very, very convoluted and difficult. So here you have fish schooled up, and as the sea lion approaches, the fish burst out in the swarm, creating a hole where the sea lion is, and the fish are generally able to get away because the sea lion doesn't know which way to go. Here you have a huge, huge flock of ducks, and there's many, many eyes on the sky, and if an eagle is nearby, if one duck flushes, then they'll generally all flush because they're all on the out, kind of looking out for danger, so there's a benefit there. Do they really want to be sitting and swimming in each other's poop? Probably not, but it's better than being eaten by an eagle, so they go with it. The group can also unite for defensive purposes. Certainly water buffalo will do this. So will musk oxen. A musk oxen herd will put the young in the herd and they'll circle up where they kind of put their butts on the baby and just have their horns facing out, and it makes a difficult thing for a wolf to get at the young. It also maintains heat, like penguins being in a big flock all together. It helps them not die of freezing to death. They have to kind of rotate a little bit, or they certainly would freeze to death. And then there's social animals. And social animals are making permanent multi-generational groups, so they live together for generations and generations, and they cooperate in their tasks. Certainly wolves and lions, they benefit because they have more people chasing food, and also the young can learn from the parents how to catch prey. So there's opportunities for imitative learning there. The bad thing about grouping up is when you do catch food, there are many more mouths to feed. So there's competition there for space, resources, water, that kind of stuff. Penguins and other seabirds form super dense breeding colonies, and when you do that, there's only so many spaces for nesting or nesting material. And when you have a million penguins on one big ice sheet, that's really going to stress the fish populations because there's a million predators there. So it also makes it a lot easier for predators to find you, even if you're a little better at getting away. It's harder for a predator to find one fish than it is for a predator to find a school of 500,000 fish. Parasites and diseases, they spread quickly through herds. Large groups are good at spreading around disease, so that's a bad thing. Now there's something called eusocial animals, and they're a little bit trickier. Pardon me, 1 second. Oh, goodness. Sorry about that. No fun making recordings when you're sick. Eusocial animals live in a multi-generational family group like we've seen, but they're a little bit different because they have a division of reproductive labor. So there's one queen, or there's one mother who's going to do most of the birthing, and a lot of other animals are going to help feed her. Think like honeybees, for example, is a great example of that. But there's sterile individuals who aren't breeding, and they care for the offspring, and they care for the queen. Some bees are like this, ants are like this, termites are like this, and in mammals we only see this in 2 species, and they're African mole rats. And they're the only mammals we've seen where there's one mother mole rat who births all the children, and a bunch of other mole rats who just find food for the kids and for the mother. And there's some discussion as to why that's necessarily the case, but here's a few examples of eusocial animals. This is a crazy picture. An Australian honeypot ant worker, and it's a sterile female, and she's literally just storing food for other ants, which is amazing. Here's an army ant soldier. another sterile female, never going to reproduce, and she has mandibles because her job is not to gather food, but to defend the colony from other insects or any other predator. Then there's a termite that has no eyes, and it shoots glue-like secretions from its head, which is sort of disgusting, and it's going to attack anything that's attacking the termite colony. So all of these are trying to basically willing to sacrifice themselves as food or as a soldier for the betterment of the colony, which is a strange thing called altruism. So altruism or altruistic behavior is a fascinating thing, but it is the idea that an animal or a person will help somebody else with no benefit to themselves. So it's a behavior that enhances another individual's reproductive success at the expense of the altruist. It's not to your benefit, it's to somebody else's benefit, like sterile workers in an insect colony. You're working and feeding other ants. Why? Why not just be selfish and feed yourself? Naked mole rat, dig for roots and take the roots to that mother mole rat. Why? Why not just feed yourself? Why do you need to feed somebody else? Here's a kind of a cool Peanuts cartoon. I'm intrigued by the view you have on the purpose of life, Charlie Brown. You say we're put here on earth to make others happy. That's right. What are others put here for? Right? That's a good altruism comic. If we're all just supposed to help each other, then what's the point of any of us kind of being here? Here you have a couple of monkeys picking, insects and parasites out of a younger monkey. Here you have a bird, helping out a mouse. It's just weird. It's a weird thing, altruism, helping somebody else when it doesn't help you. So here's the theory. Hamilton had a really cool theory about this, and he goes, well, here's the deal. It comes about by natural selection, and here's why. When you're altruistic, you're not helping yourself, but you're helping a brother or sister or cousin who has genes similar to yours. So it actually is helping you from an evolutionary point of view. If I don't do well in life, but I spend a lot of time supporting and helping my brother, and my brother goes on to have, 10 kids, and I don't have 10 kids, but because I help my brother, he and I carry a lot of the same genetics, and so those go on to his kids. And so now I have many nieces and nephews. They're not my children, but they're because I help my brother, my whole family grows in the game of evolution. That's his idea. So one hypothesis that goes kind of against this is that the naked mole rat has to be altruistic because of its environment. In where they live in the desert, their food supply is so scarce that if they don't work together, they're going to die. And so they are genetically predisposed to cooperate, share what we find. And when we're all digging, I might not find something today. But if you found something today and we split it, we're both better off because there's going to be a day where I'm finding food and you're not. So instead of every man for himself, it's let's work together, and overall we're going to be a little more stable when difficult changes occur. So let me show you some cool examples of altruism. This one's a lioness defending a fox, and so here you have a lioness with her cubs and her pride traveling down a road, and she sees an injured fox, which would be pretty easy for her to eat, I think, and she's just kind of checking it out, not really that worried about it. When the male lion comes, he decides he's going to eat it, and the cubs come and they're checking out the fox, and everyone's just looking at him. The male lion decides he's going to go in there and eat it, and the fox is just laying there, and the lioness steps in, attacks the male, defends the fox, and then the fox, I don't know if the adrenaline got its little busted leg up and running or what, but the little fox is able to get away, and then she's there with her cubs, and everybody's cool, I guess. But it's a weird example because a lion's defending a fox, which certainly doesn't carry any of her genetic material, and I don't know if it's because she had cubs with her or what's going on there, that she was just protecting little brown things. But here's another really cool study about altruism where they took rats and they put one rat in a cage that was pretty easy for the other rat to get it out. They could push the door open or push the cage over. So these rats are in one big container. One rat's in a cage and one rat's out of the cage. And so they give them this really simple example where they took chocolate chips, basically, and they put chocolate chips in the container and gave one rat the decision to either eat all the chocolate chips on his own or to go open the cage and share the chocolate chips with the other rat. And what they found were that most of the rats would go and push over the cage and then share the chocolate chips with the other rat. And that's odd because that's no benefit to them unless they're making a rat friend or something like that. So that's altruism. Here's a queen bee being tended to by her sterile daughters, altruism. Here's a queen termite, which is just massive because she's full of ovaries. And there's all of the other little offspring around her. And then here is a naked mole rat queen. Wow, what a picture, huh? And so lots of mole rats get food for her. So last thing for this chapter, think about a household pet that you have or you know. Does the animal exhibit any of the behaviors noted in this chapter? What behaviors do you think are instinctive? Which ones are learned? Does the pet initiate any communication signals with you or with other animals? My dog hackles up the hair on the back of her neck and back every time she meets another dog. And she's not aggressive, but she does it anyway. It's really weird. And can you interpret what some of these signals mean? It's kind of an example of animal behavior and animal communication. So with that, that is the whole chapter. So thank you for your time.